The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety and compliance. When installing underground electrical conduit runs, pull boxes are essential components used to facilitate the pulling of conductors through long or complex raceway systems. The NEC specifies the maximum distance allowed between these pull boxes to prevent excessive strain on the conductors during installation. According to NEC Section 300.15c, the maximum distance between pull boxes in underground installations is 200 feet. This requirement is in place to limit the pulling tension on the conductors, which can damage the insulation and lead to premature failure or electrical hazards. Exceeding the maximum distance between pull boxes can result in increased friction and stress on the conductors, making it difficult to pull them through the conduit and potentially causing insulation damage. When planning an underground electrical installation, it is crucial to carefully consider the length of the conduit run and the number of bends to determine the appropriate placement of pull boxes. By adhering to the NEC guidelines and placing pull boxes at intervals of no more than 200 feet, you can ensure that the conductors are installed safely and efficiently, minimizing the risk of damage and ensuring the long-term reliability of the electrical system. Factors influencing pull box placement include firstly, the length of the conduit run, secondly, the number and degree of bends in the conduit, and thirdly, the size and type of conductors being installed. Longer conduit runs and those with numerous bends will require more frequent placement of pull boxes to reduce pulling tension. Similarly, larger and heavier conductors will necessitate closer spacing of pull boxes compared to smaller, lighter conductors. There are several types of pull boxes available, each designed for specific applications and environmental conditions. These include metallic pull boxes, non-metallic pull boxes, and hand-hole enclosures. Metallic pull boxes are typically made of steel or aluminum and are suitable for use in both indoor and outdoor locations. They offer excellent protection against physical damage and are often used in applications where grounding is required. Non-metallic pull boxes are made of materials such as PVC or fiberglass and are lightweight, corrosion-resistant, and suitable for use in wet or corrosive environments. Hand-hole enclosures are smaller, precast concrete or polymer boxes that are typically used for underground applications where access is needed for splices, taps, or pulling conductors. Proper installation of pull boxes is essential to ensure their effectiveness and longevity. The NEC provides specific requirements for the installation of pull boxes, including sizing, support, and grounding. Pull boxes must be sized appropriately to accommodate the conductors and splices within them, with sufficient space for easy access and maintenance. They must also be securely supported to prevent movement or damage. Metallic pull boxes must be properly grounded to ensure electrical safety. In addition to the maximum spacing requirement, the NEC also specifies the minimum size of pull boxes based on the size and number of conduits entering the box. These requirements are outlined in NEC Section 314.28 and are intended to provide adequate space for bending and splicing conductors within the pull box. When determining the size of a pull box, you must consider the largest conduit entering the box, the number of conduits entering the box, and the number of conductors within each conduit. The NEC provides formulas and tables to assist in calculating the minimum required dimensions of pull boxes. Failure to comply with these sizing requirements can result in overcrowding, difficulty in making connections, and potential damage to the conductors. The NEC also addresses the use of conduit bodies as pull boxes. Conduit bodies are fittings that are installed in a conduit run to provide access for pulling, splicing, or making taps. While conduit bodies can be used as pull boxes in certain situations, they are subject to specific limitations outlined in NEC Section 314.28e. These limitations include restrictions on the size and number of conductors that can be installed in the conduit body, as well as requirements for marking and accessibility. When using conduit bodies as pull boxes, it is important to carefully review the NEC requirements to ensure compliance. Proper selection and installation of pull boxes are critical to the safety and reliability of underground electrical installations. By understanding the NEC requirements for maximum spacing, sizing, and installation, you can ensure that your electrical system is compliant, safe, and efficient. Always consult the latest edition of the NEC and consult with a qualified electrician or electrical inspector to ensure that your installation meets all applicable requirements. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect changes in technology and best practices. Understanding and complying with the NEC is essential for ensuring the safety and reliability of electrical systems. Pull boxes play a crucial role in underground electrical installations by providing access points for pulling conductors through conduit runs. They also serve as junction points for splicing conductors and making taps. Proper placement and sizing of pull boxes are critical to prevent damage to conductors and ensure the long-term performance of the electrical system. The NEC specifies the maximum distance between pull boxes to limit the pulling tension on conductors. This is important because excessive pulling tension can stretch or damage the insulation on the conductors, leading to shorts, ground faults, or other electrical hazards. By placing pull boxes at regular intervals, the pulling tension is reduced, making it easier to install the conductors and minimizing the risk of damage. In addition to the maximum distance requirement, the NEC also specifies the minimum size of pull boxes based on the size and number of conduits entering the box. This is to ensure that there is enough space inside the pull box to make connections and splices without overcrowding or damaging the conductors. The size of the pull box is determined by the diameter of the largest conduit entering the box and the number of conduits entering the box. The NEC provides tables and formulas for calculating the minimum dimensions of pull boxes. There are different types of pull boxes available, including metallic and non-metallic pull boxes. Metallic pull boxes are typically made of steel or aluminum and are used in applications where grounding is required. Non-metallic pull boxes are made of materials such as PVC or fiberglass and are used in applications where corrosion resistance is important. The choice of pull box material depends on the specific application and environmental conditions. When installing pull boxes, it is important to follow the manufacturer's instructions and all applicable NEC requirements. The pull boxes should be securely mounted and properly grounded. The conductor should be carefully pulled through the conduit and into the pull box, without causing any damage to the insulation. The connections and splices should be made according to the NEC requirements, using approved connectors and methods. After the connections are made, the pull box should be closed and sealed to protect the conductors from moisture and dirt. Regular inspection and maintenance of pull boxes are important to ensure their continued performance. The pull boxes should be inspected for any signs of damage or corrosion. The connections and splices should be checked to ensure that they are still tight and secure. Any damage to a worn component should be replaced promptly. By following these guidelines, you can ensure that your pull boxes are properly installed and maintained, and that your underground electrical system is safe and reliable. Remember that the NEC is a complex and ever-changing document. It is important to stay up to date on the latest requirements and to consult with a qualified electrician or electrical inspector if you have any questions.